Hello and welcome to this session on forensic oceanography, helping the police with their inquiry. So I'm going to talk a little bit about what we do in terms of helping to find missing persons around the UK. Okay, so first of all, just some housekeeping notes. Some of these aspects are sensitive. And whilst I've anonymised them, they may cause offence. And just highlighting it, there is nothing gory or impactful in these in this talk, but some people of a sensitive nature may be impacted. So just be aware. Secondly, we are recording this session, so if this is not acceptable, please leave, and your attendance is fine if you do leave. Please mute your microphones. There's a session at the end where we're going to have a discussion on some of the issues that have come out from this. So in this session, I'm going to have about 20 minutes talking, and then we're going to have an open discussion for about 20 minutes at the end on 3 potential topics of interest. Okay, so first of all, how does Cefas get involved in forensic oceanography? Well, Cefas provides the support to DEFRA, the Marine Management Organisation, Food Standards Agency, and the MCA on the potential impacts and trajectory of oil and chemical spills in the environment. So, what we use to identify these trajectories and landfalls? Well, we use a whole series of numerical models to predict these landfalls. So we've done, as well as oil and chemical spills, we've done a lot on containers, wood slicks, dead swans. There was a whole series of dead swans with H5N1 impact, and lost scientific buoys in the North Sea. So we get involved in these on a fairly regular basis. There's a whole series of these big, impactful events that happened around the UK, everything from the Brer up in the Shetlands, Sea Empress in Milford Haven, the MSC Napoli just on the English Channel. You just saw the picture there. And probably the most latest one, we've been working on the Wakashio, which came ashore on the island of Mauritius, and oil spilt into very sensitive mangrove areas around that particular area. And at the same time as we had the Wakashio, we also had an incident in South Wales where there was a whole series of rail cars containing 330,000 litres of diesel were derailed and spilt into the pristine estuarine environment in that estuary, and we looked at where the oil was going and where the impacts were going to be and what closures were needed in that particular incident. So as you can see, we had lots of incidents, ice prints, which produced the wood slick, which is the one on the bottom right here. And so we're quite used to tracking things in the marine environment. And so it was just a small step from there towards forensic oceanography, i.e. tracking potentially missing persons in the marine environment. So what types of requests do we respond to? Well, we only respond to search and recovery operations, and there's a distinct difference between search and rescue, which should go to the Marine Coast Guard Agency, where there is a potential for the missing person to be still alive, and where there's search and recovery operations. Hello? Okay. So the 3 types that we get involved in are once the Marine Coast Guard Agency has stood down their operations. So normally in the waters around the UK, that's around 24 hours. The waters are relatively cold around the UK, and it's unlikely that people can survive in those conditions without having a full immersion suit on. And so 24 hours is normally the duration. We can also respond to incidents where the items are found on beaches. So This could be a body that's found to know where it's come from. Quite often, there's no indication of the identification of that body, or where narcotics are found. So what we can do is switch the numerical models into reverse and do what's called backtracking from that location to where the either the body or the narcotics entered the water. So we can do those as well. We also get involved in cold case reviews. So there's instances where bodies are being found in locations around, especially around the continent, and we can help in identifying potential pathways between entering the water and being recovered. So what's the challenge associated with trying to predict these pathways? Well, the first and most critical is the location, the timing of entry into the water. It sounds obvious, but just getting this information is quite often very difficult to get from the police search advisors that are working on the ground. For instance, they may have a whole series of locations where they may have gone into the water. There may be no information about which one the missing person has taken. And so you have to have a whole variety of locations which you can explore within the model by scenario testing. The next thing that we're very keen to identify is the specific gravity of the individual, i.e., do they float or sink? Now, you can see from this particular individual on the right-hand side, this person is wearing heavy boots, heavy clothing, he's got gloves on, and so this person you would suggest is going to be quite heavy and therefore sink to the seabed. But it can vary quite a lot. The boots, for instance, may have been Doc Martin boots, so they've got air soles in them. So you need to identify what the clothing and the size and weight of what the missing person has. Also, quite often, missing people will add stones to their pockets to help them sink to the seabed. It's part of this, the psyche of the missing person. And also stomach contents, and I'll come on to the stomach contents in a minute. Well, there's 5 types of movement within the vertical water column of a missing person entering the water. So, first of all, they may come into the water and they may stay at the surface. So they just move along with the currents and stay at the surface. Secondly, they may sink to the seabed and remain on the seabed. The next type is they sink to the seabed and then come back up to the surface. So they go to the bed and then they come up to the surface. So what's the mechanism that's bringing them back up to the surface? Well, this is microbacterial activity in the gut that's producing hydrogen in that particular area. And of course, that changes their buoyancy and then brings them back up to the surface. So they've got a change in the behavior of that particular missing person. Also, you can get people who sink to the seabed and then come back up to the surface. So again, the microbacterial activity is bringing them back up to the surface, but they come from the seabed up into the water column. And then finally, there's those that sink to the seabed and stay on the seabed. They are very heavy. They've got perhaps stones in their pockets, those sort of types of issues, but they stay on the seabed. So that's the first challenge, movement in the water column. Well, the second one is the tides around the UK. Hopefully, a lot of you are familiar with the tides, but they can change in shape, orientation, size, and also time. So temporarily, they will vary due to the sun and the moon as they move around the UK. And this picture just gives you an idea, just in the southern North Sea of North Norfolk, the difference between the tidal ellipse for different locations in that particular area, and then that's just a selection of the tidal ellipses in this location. So the next issue is residual currents. There are lots of currents around the North Sea, which depend on the water coming in from the Atlantic up in the far north, for instance, and that will come down the Fair Isle Current and then down through the Scottish coastal water system, and then down the coast and then shoot off at Flamborough, heading eastwards. And likewise, there's water coming in from the Channel area and then moving up through the coast. But also, there's both the surface water and the water at depth as well. So you need to take account of where the missing person is. Are they on the seabed or not? And, so for instance, quite recently, a person was lost off King's Lynn, and they came ashore on the Swedish coastline. Quite often, there's a lot of people found on the Danish coastline as well. So we know where, on average, where people are going to end up. Okay, so how do we actually try and bring these things together? So a lot of you hopefully are familiar with this sort of tidal stream atlas that the Admiralty produce. So this is a snapshot in time showing the currents 1 hour before high water over an area of just off Cornwall and Devon, between Start Point and the Lizard. So you can see the currents in that area, and there'll be one after this. There'll be 12 of these showing you the whole of the differences in currents over those 12 hours as the tide floods and then goes into slack water and then ebbs. Well, nowadays we have a whole series of high resolution numerical models which can predict these currents at very high resolutions, using the river runoffs, the wind, the substrates, and the residual transport patterns and pathways. And what we can do is actually release particles, and these particles can either be sinking particles or floating particles, into the flow fields, to see where the particles are going, and therefore predict where the body is going to go. So let me show you what sort of flow fields we can produce. Well, that's exactly the same area there, showing all the vectors in very high resolution. So you can see how fine the predictions are. And if you can zoom in a little bit more on the lizard itself, you can see, the very fine detail you can get around certain areas. So the lizard itself, you can start getting gyres at certain states of the tide. You can, especially strong areas like the Portland Bill, you can see the gyre on each tide, and so you can get good predictions of what the pathways of these individuals are going to be. So we put these into numerical models, and we can predict these impacts. Now I'm going to now show a couple of examples, 4 examples from the output of these models. So just to get your eye in, so first of all, there's an entry point, which is this crossed hatch here, and you can actually see the stranding location, which is right up here. So for this example, this is somebody who jumped off the Firth Ford Road Bridge. At that location, they have really good CCTV, so that they can identify the time of the person entering the water, also the location of entering the water, and also what they're wearing. As said earlier, getting a really good idea of their buoyancy is key. So we did that. We got the buoyancy. We had strong winds, modest runoff. So made a prediction that it was going to be in this location, and so Police Scotland went to this location, which was 3 days in advance, and they recovered the individual within the morning. So this is a really good example of really efficient use of police resources into this location, and the use of those resources was very effective, and they recovered the body, and then they got the closure for the family, and that's the key thing that I'm trying to do here is get that closure for the family. So case 1, really good example. Everything worked very well. Case 2. Well, this is another area on the west coast of Scotland in this time, and you can see The entry point was in just off Plockton here, and in the circumstances in this case was a person, well, a group of individuals had gone ashore for a drink. I've personally done this a few times, and then when they came back, they were wearing, good PPE, and accidentally one of the people fell into the water, and he was wearing very big boots, lots of clothing, and therefore he was negative in buoyancy. So he went straight to the seabed. So that complicated things in this area. So I recommended that they stood down for 28 days, because I knew the individual wouldn't come up to the surface because of the cold water temperatures in this area. The microbacterial activity would be quite slow, and it would need a full month before there was enough hydrogen in the gut to bring people up to the surface. So that's what they did. They stood down their operations, and then they started searching in this area here. And very quickly they found the body, and they estimated that he'd come ashore 2 days earlier. Again, a good use of resources. Quickly found the missing person, and therefore got the closure. Okay, so case 3. This is another one on the Forth Estuary. So this time a missing person was involved in a road crash, and they jumped over the river, over the side of the barriers there into the water. It was estimated that this missing person would be near to neutrally buoyant, and so I did some predictions. And at this time, so it was February, there was large river runoff, so I made some predictions that the person would be downstream from this particular location. However, what actually happened was that the person was recovered upstream from this particular bridge, and the feedback that I regularly get from the police, they're very good about providing information on what they think actually happened, was that they got caught on a tree or the bridge or some obstruction, and therefore on the flood tide they moved up into that area, got caught on this obstruction, and there they remained for the duration. So in this case, I didn't do very well at all. So this is probably one of what I call the bad, not getting even the direction of a transport correct. So case 4 is back to the Forth Road Bridge again. Again, really good indication of the timing, the location, etc. from the CCTV. Buoyancy was neutral, and they got a steadily westerly wind, very similar to the earlier one. However, the model didn't predict any beaching, both either on the north side or on the south side of the estuary. So what's going on here? So this is what we got movement from the location, excuse me, to the out in the outer estuary. Now, occasions do occur where the body doesn't come ashore, even in these relatively enclosed locations. So what you can do with the modeling is you can do some sensitivity analysis. So you can change the buoyancy, you can change the timing, you can change the location a bit. And despite doing all of these things, I still couldn't get the body to come ashore. So in this instance, I was pretty confident they were still offshore. And when you get into these situations, you've got to consider that the missing persons may be impacted by other factors. And I'll just add 2 potential factors here. One is seal bite, which is relatively self-explanatory, and also benthos attrition. So if they're on the seabed, there'll be crabs and lobsters starting to predate them a little. So this is a case which I call the ugly, in that there's no closure for the family. And going back to that, there was no recovery of the body. And in fact, this was a Chinese gentleman, and actually the Chinese embassy got involved because they wanted to understand why there was no body to be found even after 3 months. And so this information was used to show the authorities, the Chinese authorities, and they were satisfied that the Police Scotland had done as much as possible to recover the body. So that's a couple of examples. We'll also get involved in higher profile cases. Going back in time, some of you may have heard of the Gaia Pope incident in Swanage. Initially, it was thought that she'd fallen into the water, so there was a lot of modelling trying to predict where she could have ended up. That was just off the coastline there, but in fact, she was actually died ashore. So that was one particular case. And then the other one is the Libby Squires case on the River Hull, an estuary there, where it turned out into a murder inquiry where she was murdered and then thrown into the river. And I predicted that she would flow down the Hull River and then come out into the Hull estuary at the Deep Exhibition Centre, and then move up and down the estuary, and eventually she was found just off Grimsby. So that was all consistent with the modelling that I did. So some very high profile cases where you had to provide expert witness reports back to the police and explore with them different locations where she may come ashore. So there was quite a lot of work associated with those. Slightly. Sorry, I missed that. On a slightly lighter note, we get reports of containers being lost in mid-Atlantic. So quite recently, two containers went into the water, one which was containing pineapples and the other one was containing bananas. And there's quite a lot of containers that are lost around the world ocean every year, so tens of thousands of containers, so it's quite surprising. Anyway, I used this as a calibration and validation exercise to see how well the models would work. So after finding out that pineapples actually float quite well, I made some predictions that they would come ashore in the Shetlands. So I put out a press release saying if anybody had found these fruit coming ashore, would be interested in the location and the timing of the pineapples coming ashore. And you can see they did. But the islanders went actually one step further, and then they actually used this to have a whole series of social media events and different activities associated with these pineapples and bananas coming ashore. So there was a lot of interest in the location and the timing of the pineapples coming ashore, and it was also very useful for us in terms of calibrating the models. So in summary, what I tried to do is get that closure for grieving families with typically 50 to 60% success rate. So the police find that really very useful. It enables them to have very much more cost-effective and efficient search and recovery operations around their coastlines. So I'm on speed dial for a whole range of different authorities around the coastline. It can be used in incident and criminal investigations. I mentioned the Libby Squire case, but also the April Jones case in West Wales, McConaughey. So it can be used to try and work out where parts of bodies could have ended up. So we did that. We did that. It will also be used in what's called backtrack mode, as I mentioned, to find the sources or entry points of either missing people or narcotics around the coastline. I haven't shown you one of those, but it works fairly well. And finally, how do we actually fund this information? Doing this work is directly through directly with a contract, Cefas Connects. So that's Cefas trying to work with the community in different locations around the UK. So that funds these particular projects. Okay, and thank you very much for listening. Now we'll go into questions. Hello, can you put your hand up if you've got a question or Becca?
Hi, John. It's just, how many do you get a year? Like, how many types of modelling do you do a year and requests?
At the moment, I give out one a fortnight, so 100 a year, so quite a lot. They tend to come in waves, and I'm not sure why that is. Quite often it can be associated with Christmas and New Year, where people may get depressed and therefore may consider taking their lives. But there's a lot of work going on about trying to make it very difficult for people to get to known locations where people may have entered the water before. So there's a place near Swanage called King Harry Rocks, and there was a lot of suicides in that location. But recently what they've done is they put up a whole series of barriers, along with please contact the Samaritans in locations along there, and that's significantly reduced the number of people that are trying to commit suicide in that location. So yeah, it's surprisingly how often I get called up.
Thanks.
Emily.
Hi, John. Thank you very much for that. That was really, really interesting to hear everything that you've been doing in this. I was wondering if you ever use any other sources of information that you get. So the context, from what I'm aware of, I used to work for the RNLI, and colleagues there have now gone on to do their own research projects looking at using drone technology in association with police force and the MCA to look at mainly recovery, but also obviously best case scenario rescue. But I'm wondering if you would ever, or if you have in the past, looked at combining the kind of model outputs you're getting with anything else kind of in situ like that.
Well, one of the things that I use in situ already is I use WaveNet, because as well as measuring the waves, it measures temperatures. So that's one of the things I'm really interested. So if you go to the WaveNet website and then go to the map and then go to the right-hand side, you can pull down a parameter. Instead of significant wave height, you can put surface temperature, which gives you a map of temperatures around the UK. And of course, that's so variable depending on the time of year, etc. So that's one use of remote sensing technology. Another one is I do use satellite information. So we have direct within DEFRA, we have direct access into the Sentinel satellites. So I do use those through one of their systems. But again, you're limited to the resolution of Sentinels, which is 10 meters or so. It'd be nice to be able to have super high resolution. But there are systems within Copernicus, which is the European system, where you can have in emergency monitoring systems, EMS, you can instigate those incidents in a major incident, and therefore you can get a whole series of products from a whole range of satellites, both the Sentinel series, but also the commercial sector as well. So you can get really high resolution imagery from those. So, starting to get down to 1 meter sort of resolution. So again, great for, planning your search operations, but they're not going to be used in a real-time mode, to identify a body, but, putting into context the information that I'm supplying.
Yeah, brilliant. Really, really interesting. And is there anything else that you do in terms of training? So going back to the sort of local police forces and giving them any kind of training, and so they can understand your work better when you're collaborating with them on these events?
Yes, I do. There's a Coast Safe forum down in Cornwall, and I gave this talk, or a modified version of it, to them, which was earlier on in the year. So again, they can see where I'm coming from in terms of the the strengths and weaknesses of the approach that I'm using, and the sort of information that I will provide, and also how we try and give that back to them.
Brilliant. Thank you very much, John. That's great.
Pleasure. Katie.
Hi, John. Thanks for that. You talked a lot about how the inputs to your models are important. I just wondered if there were any kind of improvements you had in mind for the actual models themselves. Are there any ways that you think they could be developed to improve your results?
Absolutely. What's happening is a lot of the responders are wanting to know which side of the headland a missing person is going to come ashore. Is it going to be in the morning tide or the afternoon tide? So there's an ever increasing expectation that the models will provide this. And so what we've got to do in terms of the modeling is improve the resolution associated with the models. So at the moment, we're using one of the models that we have running in Cefas, which is at about 1 kilometer resolution. But there is a case for going to higher resolution models in estuaries, where we get a lot of incidents, or there's a lot of impact or potential impact from oil spills. So places like the Thames, the Southampton water, etc. So I think what will happen in the future is that we'll have a whole series of models that we can dip into, depending on the circumstances, to produce the higher resolution and therefore the higher accuracy models.
Thanks, John.
Thank you very much, everybody. I think we've just about come to the end of our time. If you want to send me anything, my email address is john.rees@cefas.co.uk. Very happy to answer your questions or continue this conversation afterwards. Is there any other questions? As it's gone silent, I think we'll call it a day. And thank you very much indeed for participating.
Thank you very
Thanks,
much, John.
Thanks,
Pleasure.
John. Thank you.
Thanks, that was great.
Thank you. Bye.